All right, guys, well, this is it. We're finishing up the exam today. I'm proud of each and every one of you for continuing to work hard, and you're going to do amazing things this week. All right, so we have a nice independent question. So I'm going to go over both ways because we should know these forwards and backwards. So I'm comparing blue eyes to glasses. So the probability of blue eyes given glasses is equal to the probability of blue eyes. Okay, so that's way one. Way two is the probability of blue eyes and glasses is equal to the probability of blue eyes times the probability of glasses. Got to know both independent formulas. That was on our must-know sheet. Must know, must know, must know. So let's find some tallies here. That's 0.35, 0.65, 0.4, 0.35, 0.25. Does that get me a total of 1? Oh, that's nice. Okay. The probability of blue eyes given glasses. So I had to be in the glasses group. So that's 0.35. And out of the friends that wore glasses, the blue-eyed people were 0.14. Now I want the probability of just having blue eyes. Okay, out of the whole group. It's not out of the given group, it's out of the whole group. So blue eyes would be 0.4 out of 1. And then I just want to show the greater. Either those are the same and they're independent, or they're not, and they're not independent. I've got 0.4 equals 0.4, so wow, independent. Now, it should work the same with this one. I want blue eyes and glasses. So I'm looking for, here's my glasses friends, here's my blue eyes friends. They meet at 0.14 out of the total group. Again, if it's not a given, it's out of the total group. So then I want the probability of blue eyes, which is 0.4, and the probability of glasses, which is 0.35. So I want to know if those are equal. So 0.4 times 0.35 is 0.14, which of course equals 0.14. So again, wow, independent. Works both ways. Okay? Pick the one that works for you, but it works both ways. Okay, 30. We haven't done one like this in a while. So here's how I tackled this one. I know the cube root means that in a fractional exponent, the root goes on the bottom. So I said this is 81 to the 1/3, x to the 15/3, and y to the 9/3. And somehow that has to equal 3a, x to the 5th, y to the 3rd. And I was like, darn, that's pretty close, right? Why is that close? Well, what's 9 divided by 3? 3. Oh, look, y to the 3rd. What's 15 divided by 3? 5. Oh, look, x to the 5th. Okay, now it's telling me I have to make this look like this. So somehow this has to become this. So 81 to the 1/3 has to become 3 to some power. How am I going to make that happen? Now, we haven't reviewed this a ton. I'm not going to lie. This kind of fell off the wayside. We did something called common bases. We said, how can I rewrite this number so it has a base of 3? Well, I know 3 to the 1st is 3, 3 squared is 9, 3 to the 3rd is 27, but 3 to the 4th? Now that's 81. So I'm going to call this, I'm going to replace 81 with 3 to the 4th, and it's still to the 1/3. Now I'm starting to look a lot closer. Now what do I do with power to a power? I just multiply. So what is this telling me? That a must equal 4/3. Okay, and again, that's been a while since we tackled that one. But go through again, try to work it out again on your own and talk yourself through it. If you didn't get it, of course. 31. Graph on the axis below. All right, so let's start with our main stuff. Midline is 5. Amplitude is 2. So I'm going to start with 5. 1, 2, 3, 4, 5. Amplitude is 2. That means I have to go up 2 and down 2. So 6, 7, and 4, 3 are my maxes and my mins. Okay, now remember, all of graphing is about period. So it's 2 pi divided by the frequency. So in this case, that's 2 pi divided by 1/2. We do a keep, change, flip. That tells me the period is 4 pi. So I will see one full cycle at 4 pi. However, this graph says I can only go out to 2 pi. So I'm going to make my pi over 2, my pi, my 3 pi over 2, my 2 pi. So I want you to be smart now. You don't see the whole graph to 4 pi, which means you're only going to see half the graph at 2 pi. Half the graph. Now it is cosine, so I'm going to draw a quick sketch. This is what cosine looks like. Starts at its max, ends at its max. But I'm only going to see half the graph. So I'm going to see it start at its max and end at its min. So it's going to start at 7. At 2 pi, it's going to end at 3. Smack in the middle is where it's going to cross. So at pi, it should hit here. Now just make sure it's not a straight line. It's a curve. It goes concave down and then concave up. So I see the whole graph, excuse me, at 4 pi. I only want to see half the graph at 2 pi. 32. Write an exponential regression. So great review on that. Everything goes into this calculator. So stat, whoops, edit. Everything goes in here, 0, 5, 10, 15, 20, 25, 180, 144, 120, 104, 93.3, 86.2. All right, we're going to go stat, arrow over to calc. We're looking for exponential regression. It's in L1, L2, and then just create it for us. Calculate this regression. So what am I showing the grader? This is the equation, AB to the x. It says use your model to round to the nearest thousandth. So I got to do this correctly. So my A value is 169.10 hundred thousand and 0.10 hundred thousand to the x. Actually to the t. And I need to call this f because it says f. So I'm going to put f of t, let me kill my y here, f of t equals this equation to the t. And again, I'm using f of t because that's what the direction said, so my function is f in terms of the letter t. Easy, easy couple points there. All right, on to the 4-point questions. On the same set of axes, graph this function. So again, guys, the calculator is doing 90% of the work for us here. So x cubed minus 3x squared and 2x minus 5, x cubed minus 3x squared, 2x minus 5, zoom 6. So I'm going to see what it looks like first. I see 1, 2, I see 3 intersections. It doesn't look like they're going to intersect again, but I'm going to get this graphed out nicely. All right, so my blue graph, I'm just plotting points. Perfect points. At -1, I'm at -4. 1, 2, 3, 4. At 0, I'm at 0. At 1, I'm at -2. 2, I'm at -4. At 3, I'm back to 0. At 4, I'm at 16, so I'm way up there. So now before I connect that, I want to get the vibe down, right? I want to say, okay, it goes up, hits its max. I'm looking at the picture as I do it, goes back up. Okay, arrows on the end because there's no domain. Now I'm going to grab my red graph. Let's see, at 4, I'm at 3. 3, I'm at 1. At 2, I'm at -1. At 1, I'm at -3. Keep going a little here. At 0, I'm at -5. 1, 2, 3, 4, 5. Then -7. I think I've got enough to make a straight line. Okay, it matched up what it looks like. State the number of solutions when f of x equals g of x. So again, that's an intersection. We've said that 10 million times this year. If two things are equal, we're looking for the intersection. Now, it didn't say state the points, it just said state the number of them. And clearly, there are 3 of them. All right, a Fulcant pendulum can be used to determine or demonstrate that the Earth rotates. The time in seconds it takes for one swing or period of the pendulum can be modeled by this equation, where L is the length of the pendulum in meters, G is a constant. Okay, so G is just always this number. That's what constant means. The pendulum length was 67. So what letter are they telling you? I mean, match up the words. It's like Sesame Street. Length of pendulum, pendulum length. They're giving you the letter L. Determine to the nearest tenth of a second the time it takes. Okay, so you're fine. Here it is. The time t in seconds. So you're determining the time it takes. You are finding t. So I'm finding t, which means I should know everybody else. They just told me L is 67, and they said G is a constant 9.81. It is always 9.81. It's kind of like I don't know. I don't want to say embarrassing, but I'm not sure why they're asking us just to plug this in our calculator. It's like they ran out of questions to ask. We've got 2 pi square root 67 divided by 9.81. And we just got to round correctly to the nearest tenth of a second. I'm getting t equals 16.4 seconds. All right, another pendulum in the United States building takes 9.6 seconds to complete one swing. Determine to the nearest tenth of a meter the length of the pendulum. So now we're finding the letter L. Okay, and they gave you 9.6 seconds, which means they gave you the time. So now I'm saying 9.6 equals 2 pi the square root of L over the constant 9.81. So now they're just testing if you can solve a radical equation, which you should be pretty darn good at. Step 1, of course, is to get the radical by itself. Now, there's only one mistake that students make. Okay, you will get a different answer. You have to use the fraction tool, guys. You have to pull up 9.6 divided by 2 pi. All right, I'm just going to show you. If you didn't, and you just typed this in, you get the wrong answer. This is incorrect. Okay, so you have to use the fraction tool. 9.6 divided by 2 pi. So I get this lovely 1.527 number equals the square root of L over 9.81. Then my job is to do what to both sides? Square them. So I'm just going to square this number on my calculator. I'm taking that answer and squaring it. So now I've got 2.3344, etc. is equal to L over 9.81. How am I going to get L by itself? Probably going to put this over 1 and just cross multiply. So I'm going to take that number times 9.81 to say L equals, oops, I missed my decimal, 9.81, 22.9, because I think it's the nearest tenth of a meter. Whoops. All right, 35. Oh, a nice stats question here. In order to decrease the percent of residents who drive to work, a large city launches a campaign about public transportation. Before starting the campaign, they estimate that 65% of its residents drive to work. Okay, so this is the proportion of residents who drive to work, and they want this 95% interval. So again, we want the margin of error, which is 2 times the standard deviation. Okay, and that's given to us, so I'm doing 2 times 0.034. So I'm getting a margin of error to be I missed my decimal, but I can do that in my head, 0.068. Okay, and then I need the 95%, so I need the mean plus and minus my margin of error. So I'm going to take my mean of 0.651 plus that number, and then the mean minus that number. And it says to the nearest hundredth, so now I have to round correctly. 0.58, comma, 0.72. Easy 2 points. 1 year after launching the campaign, the Department of Transportation conducts a survey of 200 randomly selected city residents and finds that 122 of them drive to work. So the question is, did their campaign work? Did more people start driving to work? So let's see, 122 out of the 200 people is 0.61. Now, where does 0.61 fall on my confidence interval? Shucks, it falls inside. Okay, so was it effective? Did it change the outcome? Well, all these people were already driving to work. Okay, so did it affect the outcome? No. 0.61 falls inside the 95% confidence interval, which means it's already likely to happen. It's already happening. 95% of the time it's already happening, so it was not effective. Oh, nice system. We love these systems. All right, so we always solve the linear, solve for x and y. Hopefully your gut's saying y in this case, because the x would be a bear to get alone. Okay, I'd have all those fractions. So I have y equals 2x minus 5. Now I'm substituting that into this y. So I have x squared plus 2x minus 5 squared equals 25. foiling that out, I'm going to get 4x squared minus 10x minus 10x. I'm going to say minus 20x plus 25 equals 25. That's going to get me a 5x squared minus 20x, and I think those cancel each other out to get an equals 0. Then two terms, I'm always either saying, always GCF first, GCF or dots. Clearly I have a GCF. I'm going to pull out a 5 and an x, and then I'm left with x minus 4. I can tee that up. I have two x's, so I have two answers. I have 5x equals 0 and x minus 4 equals 0. Divide out my 5, and I get x equals 0. And here I get x equals 4. Now I'm not done there because it's a system. A system is a point for an answer. So I need to plug 0 back in, and I'm just going to use this equation. If I plug 0 in, 2 times 0 is 0, minus 5, I get 0, negative 5. And I'm going to plug 4 in. 4 times 2 is 8, minus 5 should get me a 3. So I have two answers to a system, and again, a system is always points. All right, well, we've made it to the last bear. Oh, we haven't seen one of these in a while. As a 6-point question. The population in millions of people in the United States can be represented by the recursive formula. So again, it must be using a sub n minus 1. There it is. Where a sub 0 represents the population in 1910 and n represents the number of years. Identify the percentage of annual growth rate from the equation. So I'm taking the previous term times the growth rate. Now I know it's growth because this number is bigger than 1 is telling me it's growth. But what is the actual rate that it's growing by? I have to move that decimal back. Remember, what percent did I add on? So it was 1 plus the rate is equal to 1.015. So the R value must be 0.015, and it says what percentage? So that's 1.5%. Write an exponential function p, where p of t represents the population in millions of people. Okay, so p of t. So I have to start with my initial amount of people, which a sub 0 would be my initial amount of people. My growth rate, 1.015 to the t, because it's happening every year, annually. According to the model you just wrote, determine how long it will take to reach 300 million people. Okay, now, this was already in millions of people, so I can use 300 versus 300 million because this equation already represents millions. I'm going to highlight that again. This is the population in millions of people. So there's 92.2 million people. So I'm saying 300 equals 92.2 times 1.015 to the t. Remember, base and exponent married, can't break them apart. So 300 divided by 92.2, this lovely number, 3.253796 equals 1.015 to the t. All I have to do is convert this to log base exponent. Log base is 1.015. Flip-flop, 3.253796, etc. equals t. So I'm going to pull up my math, log base of my 1.015, and then this is this level, whoops. Number there. Oh, I put it in the wrong spot. Math 1.015, and then I want this number here. So I'm going to get t equals 79. How did it want me to round? Round to the nearest year, so 79 years. All right, guys, you've grown immensely this year. You've done a great job on all these reviews, and I'm excited to see you show off your skills tomorrow. So just a reminder, I've got the wrong sheet here. That's my problem. We begin at 7:30 tomorrow. Make sure you're ready to go. I believe these are the rooms. Period 3, I think you got moved to, 144, 160, and 166. So I think those were normal on yours. This is just an old sheet I had before I redid it. But 144, 160, 166. Bring your pens, pencils. Remember, everything is done in ink except the graphs and your charged calculator. And we're ready to rock and roll.